Hi, I'm Dr. J.R. Skoke, the Chief Science Officer of AstroReality. And today we're going to talk a bit about some of the natural disasters that are always facing Earth and how we can explore some of that within the AstroReality Earth dataset. Now, right now, we are dealing with an unprecedented in the modern medical era, the pandemic caused by the COVID-19 disease. And one of the scariest parts of this disease is how it's overwhelming medical facilities around the world. When we have a number of cases in any area, any town, city, state, it completely overwhelms the capacity of hospitals and beds and the equipment we need to take care of people. And this puts a lot of stress in how do we care. And so far, many of the usual natural disasters that often face much of the world have been a little quiet. So we're able to focus in on the taking care of people from this disease. However, the Earth doesn't stay quiet. It's continuing to churn, and all the usual hazards that face us can happen at any moment. And so we're going to explore some of those hazards that always face Earth and some of the consequences that might come from them, and see how we can explore them in the Earth data set. And hopefully we won't be facing these until our medical facilities can handle more of the capacity from the COVID pandemic. But with the season changing, we're going to be facing more and more dangers from the typical natural disasters that happen around Earth. So on our AstroReality Earth app, hopefully you can see here, as I mentioned, the Earth keeps on churning. And much of the surface of Earth is broken up by our plate tectonics. We can explore the natural fault lines that happen around the Earth, where in our land and fault line layer, we see places where the boundaries are diverging, leaving apart in mid-ocean ridges, places where they're convergent in green here, where they're colliding, and places where they're convergent in kind of purple, and sliding past each other in transform faults in green. And wherever these lines show, we usually have earthquakes happening as the plate tectonics of Earth are moving around, building mountain ranges, and changing the surface of Earth. Now, earthquakes are often focused in two of these types of zones. One is these convergent zones. These are some of the largest earthquakes on Earth, is where we have these purple layers. And that usually happens where either two continents collide or an ocean goes underneath a continental crust. Some of the largest earthquakes in recorded history actually happened off of South America, creating the Andes as the plates go under and push up the Andes and scrape by and cause major earthquakes. Similarly, large earthquakes happen throughout the whole ring of fire, from sliding underneath Alaska, going under Japan, and throughout the South Pacific. In addition, in America, lots of population is at threat from transform faults. Places like this green San Andreas fault is always in the news that cuts right through California. Here, the plates are sliding past each other, creating a great threat for the tension in the rocks to break, causing the earthquake to move through the lands, which would shake buildings, cause bridges to collapse, cause gas lines to explode. All the kind of disasters we often see from earthquake events. We often have earthquakes that aren't exactly on these lines either, because while we can see the surface expression of these faults in our app, they also extend underneath the planet. So just this past week, we had a fairly large earthquake, magnitude 6 near Idaho. And last week we had one in Utah. Now these were not large enough to cause too much damage, and were, I think, fairly deep, because that's where the subducting plate hits the surface plate is fairly deep by the time it gets into the western states there from the Pacific. However, if those earthquakes are bigger, if they happen in a place that has weaker buildings, that can cause a severe damage, injuries, and even more disasters that's going to overwhelm an already stressed medical infrastructure. And so luckily, earthquakes don't really have a season. They just sort of happen when they happen. So we can hope that these earthquakes will not happen until we figure out our no major earthquake can happen before we get through some of the main challenges of the COVID pandemic. However, other disasters, other challenges that face Earth are more seasonal. We are now just entering springtime for much of America. And in a lot of places, especially in the East Coast of the US, some of the places that are facing some of the largest, fastest outbreaks in in the world right now, including New York City and New Orleans, Louisiana, these are places that are going to be facing a lot of rain coming up in the next few months. And places that still have snow will accumulate that, where rain and snow melt will cause extended flooding. And so much of the East Coast, from throughout the Mississippi Valley and coastal US, exceeds lots of precipitation, causes rivers to flood, and flooding causes property damage as well as accidents from the rain, as well as, depending how bad the flood is, if cities are inundated, that can close down entire hospitals, which would even more stress the pandemic situation. So this is one that we know is coming, that there will be a fair bit of flooding coming in the springtime. And so watching for that, knowing when it's expected to be, looking at places where snow melt will be most likely to melt in the coming weeks, will allow us to predict which hospitals are most in danger from kind of seasonal flooding. And following along those lines, in a few months' time, we're going to be faced with hurricane season. Now, hurricanes often develop near the equator, just off the coast of Africa. This here shows thousands of Earth hurricane tracks as from 1950 until 2005, as they crossed over the Atlantic and throughout America. And we see buried under this data is a lot of the southeast US. Florida, which is having thousands of new cases of COVID. If it gets one of these hurricanes coming up in summer to late summer, entire cities can be shut down from from hurricanes, as the danger from the winds could be shutting down buildings, breaking windows. Flooding from surges can also flood out hospitals and other facilities, causing even more stress on an already overwhelmed medical system. In the US, in the Western US, we've dealt with fires a lot in the recent years, and we expect very hot summers to continue out in California, in Colorado, in Utah and Arizona, places where every year we have incredibly large and often destructive forest fires. And this summer, despite the fact that we're all focused on the pandemic, those fires will happen again. They're going to cause injuries as people try to flee their houses or are dealing with fighting fires. They're going to shut down, there could be burning down hospitals or towns, causing people to evacuate, causing people who should be sheltering at home to have to escape their homes and go to other places, causing possible vectors of the disease. So while we're facing this unprecedented pandemic, there are so many ways that we need to prepare now through storing food and watching for these conditions. Some we can predict and other ones we can't. But these are all ways that the natural pulses of the Earth could kind of exacerbate the current pandemic situation. Thank you. So I think that's the introduction to our data, walking through that. I can take questions if people think that there's more to say, and we can edit them in, or.
Sounds good. I think it's a very good introduction. Are there anyone have questions interested in natural disasters as the earthquakes and other natural disasters? If you have.
I don't have any questions, but I think it really kind of highlights a lot of really interesting things that are going on about just our world and how many other potential issues that can lie, but also positive things and outlooks on it. I think the data sets are also looking really, really cool, especially from a visual perspective. And so thank you very much, JR, for organizing all that. Again, it's really impressive and looks really well. Really, very, very informational. Thank you.
Thank you.
Yeah, great. It's very informative, and we keep navigating this critical challenge, but also we want to pay attention to other events happening on Earth as well. JL, I have a question in terms of, actually I have seen this a couple of times about heat wave and happening on Antarctica. What do you think about that? Probably that topic is also related to global warming. So what are your thoughts about that?
Yeah, so part of global warming is that it's going to be happening every year. So every year, we're going to be having average temperatures increasing. There may be local minimums here and there, it may cool down for a season in part of the world, but on average, things are going to keep on getting warmer as we have more CO2 emissions. And so every single year we have new heat records, from small places to large regions to the entire globe. And so this year we had, I think it was a part of Antarctica was over 60 degrees Fahrenheit. So like a very warm day for the first time in recorded history. And when we say recorded history, that's because that's when we have very good temperature results, where we have like thermometers there and can record it. But because we can look at ice cores and other things that proxies for temperatures, we know that not only is it recorded for the last century that we've been actually measuring with thermometers, but for the last several millions of years, we're in one of the warmest times. I think we have to go back many hundreds of thousands of years, and soon we got a time that's at all close to the kind of warmth that parts of Antarctica are feeling now. And it's never gotten this warm this quickly before. And so, that's going to continue to kind of destabilize the ice that is in Antarctica, causing more ice to kind of melt off the surface, causing sea levels to rise. As the kind of ice store on Antarctica melts and washes the ocean, we have sea level rise. We have kind of a main store of fresh water and cooling on Earth is melting, causing even more heating to happen as a kind of a cycle back feedback loop. And so, while it's a major thing to see this kind of mark of how warm Antarctica is gotten this year, it will almost certainly be beaten by next summer. So probably next February, January is usually the height of the summer season in Antarctica. So even though we're breaking records, we're probably going to break more records each year until we can find a way to stop our CO2 exhaust.
Well, sounds good. Well, you mentioned about finding a way to stop this happens. What are the ways that we found might probably work from scientists' point of view for now?
So there are a number of ways. So our heat on Earth basically comes from the sun, and then the heat energy kind of is collected and kind of stored based on greenhouse gases in our atmosphere. And there's a number of powerful ones, and the most common one that we can really control is CO2. And that comes from burning fossil fuels. And so we need to find a way to get carbon dioxide out of our atmosphere. It has been since hundreds of thousands of years, since the Earth was completely different, that we've had this much CO2 in our atmosphere. And we've never had a time where we put this much CO2 into our atmosphere. Now, what fossil fuels are basically preserved carbon from hundreds of millions of years ago. Trees that existed hundreds of millions of years ago, sea life that existed hundreds of millions of years ago, these were made of carbon, and they were removed from the atmosphere, removed from the water as they lived and died and were put into rock and stored underground. So what we're doing now is every time we burn coal or burn oil, burn gas, we're taking this fossilized carbon dioxide that's been buried for hundreds of millions of years and putting it back into the atmosphere. And so there are ways for this system to kind of fix itself. Every time we erode a rock. So one of the things that caused Earth to get cold fairly recently in the last few hundred million years in this part of Earth history was the creation of the Himalayas. As India collided into Asia, it forced up the Himalayas, causing a lot of erosion as the rocks got really high and started to fall and erode much faster than they usually do. And as the rocks erode, they would suck in carbon dioxide from the atmosphere, pulling it from this kind of CO2 budget we have. And so it's this geology that led to erosion that caused CO2 to drop fairly, in this geological era. So there are ways for CO2 to come out of the atmosphere, but they take a long time. It takes millions of years for the erosion of the Himalayas to remove the carbon dioxide that we're now putting up there in years or decades. So in order for us to allow the natural systems to kind of correct, we basically need to stop artificially putting carbon dioxide into the atmosphere. So that means basically changing how we produce energy on Earth. So rather than burning coal, which already because of financial economic reasons, a lot of the Earth is stopping a lot of coal burning. We're moving to cleaner gases, natural gas, especially because it's a lot easier to move and pretty plentiful, and oil are still kind of the main energy sources on Earth. But as long as we're using those, we're going to keep putting CO2 in the atmosphere, causing temperatures to rise. So the only real way to stop this rise is to stop burning natural fossil fuels as the main energy source. Now, other things can help with the problem. Massive forestation, like planting forests everywhere we can, that can suck in carbon dioxide from the atmosphere, put it into plant matter. And so that has the potential to help a bit on the removal process. But really what we need to do is stop emitting it and allow the natural systems, the oceans and the rocks and the atmosphere to kind of go back to their kind of original feedbacks to kind of make the system a lot more stable. So really fixing our energy uses, going to renewables, using solar, wind, hydroelectric, geothermal. Those energy sources are, there's pluses and minuses to them all. But as far as the global warming and CO2 release, they're much better on that front.
Great, thank you. It's definitely very beneficial to know Earth is creating events that can eliminate that or help with that. But what do you think about things that we need to have in mind as the audiences who are listening to this or who are watching this? What do you think that means to our daily life? How do you think us as each individual can do to help with this process?
So I think the number one thing that every person needs to contribute is the concept that they can help, that this can be better, that we can win. Because if we don't think we can do it, then there's no chance that we can. So what we need is for people to be confident that we can build a more stable future. And so once you decide that we can do it, we can remove, we can stop our use of CO2, then it becomes kind of looking at the best choices we have. Now, for most people, if you go back a month ago and you say you need to stop driving to work, now that would be career suicide for millions of people around Earth. But now with the pandemic, so many people who used to have to drive to work every day using fossil fuels, using oil, using the infrastructure, now they're found that they can work from home. And so I think the showing that we can completely change how we live to deal with great crises, that's something that I personally didn't know if humans had the willpower to do that before the COVID pandemic. But now seeing that when we see a crisis, when we see that it can cost us our lives, it can cost us the lives of grandparents, people we don't even know, we're willing to, stop going to restaurants, stop going to bars, stop driving to work. These are changes that we can make if we decide that the reason to do so is enough. And so I find that very hopeful that, giving two choices, we can do the one that may lead to a better outcome if we believe it can happen, and we create a system that allows the resources for us to actually work with that. So now that we have a culture who says, yes, for the safety of population, save energy by working from home, all these things are now being built into our society. And I'm hoping that those lessons can then be applied to the climate crisis that is, happening all around us right now and will only get worse in the future.
I really love that. I really like what you just said there, JR. That was a really great thing. That kind of helped me kind of think back to this the origination of this thing. And I think it's really that's a great perspective to have. And I want to just echo that again. That is, I really think that's fantastic that we can do that. And it's seeing that these action points have happened. And despite this tragedies that are occurring and the dramatic toll that it takes, that we are all collaborating together and that we are working together through this. It's truly valuable to see that. And I'm happy that you brought that up again.
One of the challenges is that we get motivated to solve problems when when it affects us. So right now, the challenge of COVID is that for the most part, the main toll will be on the older generation. They're the ones who are most likely to perish or be have like a very big loss of life and quality of life in this. No one is immune. There's people at all ages of all healths are being affected by it. But the fact that we can see that this disease is a threat to basically every person's parents and grandparents, that makes the threat kind of hit home. And I think that is what causes us to take action. One of the challenges with dealing with climate change is that our industrial society, especially in richer countries, America, Europe, parts of Asia, is that our industry and our economy can protect us from the worst of it. So if you're in America and sea levels rise, it might be as bad as moving to a different house farther from the ocean. If you're living in floodplains in Bangladesh, that could mean that your entire region is now flooded and you can't afford to go. So one of the challenges of climate change is that the poorest people on Earth are paying the greatest price. And the people who are then able to kind of choose to live better are kind of separated from those people who are paying the price for it. And I think that has been one of the biggest challenges of having worldwide actions on climate change, is that the people who have to pay the price to make the changes are not the ones facing the consequences. However, now with COVID, we're seeing that the same people who can make a difference, they're trying to save people in their lives. And I think that connects the choices we make and the changes we can apply to the feeling of consequences and the feeling of involvement that makes us have a stake in the game.
Great. Thank you, JR, again. And I think it's a wonderful talk. And those are wonderful thoughts from you and our team. Thank you very much for all. And I think, unfortunately, our time is up. But we would like to continue this talk again next time. But thank you very much for all for today.
Thank you. Have a great day.
Thank you.